Okay, the program that you guys are going to do is you can choose any program 1 through 7 from chapter 10. That actually starts on page 692 in your textbook, page 692 in your textbook. And we want you to use pointer notation rather than standard array notation when you are working with the arrays in those programs. And you could incorporate that into a current working project if you want as well. I am going to just show you, hopefully briefly, some examples from chapter 10, just to reiterate what the PowerPoint slides did just a little bit. I'm not going to run any of these due to time and finagling back and forth between the compiler, etc. But if you take a look, now this particular program, I would tell you not to declare any of these variables outside of main, but they have here. And they're going to print the address of the variables by using the ampersand. So if you were to run this code, it's going to print the address of those variables. I would have declared those locally. I honestly don't know why they declared them outside of main. Here's an example. If they just declare an integer variable x and then you dereference the pointer to that variable, you can point to an integer. Then the pointer is going to equal the address of x, and it stores the address of x in a pointer. And if I want to print the value of it, I'm going to print x. If I want to print the address, I'm going to print the pointer, PTR. So notice, if I create a pointer here by using the asterisk, but when you use the asterisk up here, it's not dereferencing. You only dereference, it's only called a dereference operator when you use it like in a cout statement. To get to the value. So when you're declaring the pointer, you use an asterisk to say that it's a pointer, and then it's going to, if you output at PTR, it's going to be the address. If I wanted to output the value 25, instead of saying X, I could output asterisk PTR, and that would dereference. Actually, it might be asterisk X there because the pointer is pointing to X. I'd have to actually test it out. So that might be something that you could test out. Same idea here. They're just a variety of different programs that show you the pointer notation. And it says assigning 100 to a location. So I have to use the asterisk and it's going to assign 100 to X. And then if I want to use X and R to display. So actually here's the answer to the previous question. You can display with an asterisk PTR, and it's going to say, once again, here is the value. So you just need to have the asterisk PTR in order to display it. You wouldn't have to print asterisk X. Okay. Other examples using pointer notation and using the, this is the address operator. So when you assign a pointer, you have to assign the address. So I'm going to assign the address of X, address of Y, address of Z, etc. I want to get down to this is just showing how you can use a pointer. And it says the first element in the array is asterisk numbers because it's dereferencing numbers. You don't have to declare a special pointers up here because arrays are automatically declared that way behind the scenes. We don't realize that until now. So it's automatically, basically when you declare an array, it's automatically kind of doing this where it's creating a pointer to the array. So if I want to dereference, I use the asterisk. If I want to dereference past that value, remember I have to take the name of the array plus whatever index I want to move towards. If I add 1, that's going to be the second item in the array. If I add 2, it will be the third item in the array. This also explains why arrays have a starting indice of 0, because you're pointing at the address is the 0th element when we output it here. And then you have to add 1 would be array position index 1, which is the second position, and etc. And they just have a variety of other examples here that you're going to want to use. This is what we're talking about when we ask you to use the array pointer notation. So when you work with your loop and output it, we want you to use the pointer notation to output it. When you're inputting, you can input using your regular notation with the brackets, but when you output, we want you to use the this type of line of code here, where the cout asterisk coins plus count. So you're using pointer arithmetic. And they have a variety of different examples that we'll talk about. And this one shows setting precision, declaring an array, declaring a pointer, setting the number pointer to the array. And then this one's using this one's incrementing to the next pointer and then just printing out using the dereference operator here. So there's a variety of examples in the Chapter 10 folder that you guys can use. You do not have to modularize this particular program. You can if you like, and there are some examples here. For example, program 11 and program 12, etc. They show you how to pass values with pointers. So that would be kudos to you if you do that. That would add to your potential grade for some of the modularization if you need to recoup some points somewhere. Using parameters in a program like this, not parameters, but using modules in a program like this would be a bonus. It also shows you here how you can create a class, and then you can create a pointer to those objects. So I have a pointer to a rectangle and a pointer to a person. Okay, and likewise we have similar. You have the prototypes before main if you're going to modularize. Then you have main, and then you have the methods below. So if you want to do some modularization, if you have some extra time and you want to pass pointers, then that would show that you have a deeper understanding and would be more of an exemplary grade, which would be an A grade rather than a high proficiency or a B grade. So please take a look at the resources that they have here. I believe one of them actually reads in from a data file. I am not sure, but I did notice that they had a data file up here. Nope, they didn't. They actually, it was a class. I thought they had a data file. All right, well, that kind of wraps up the examples from your source code. Use those when you're writing your textbook examples. The only other thing I'm going to mention is that we do have, and I believe if I don't have it posted on course sites, I can get it there. And it's actually under the inheritance information, is that we have a project that uses pointers, vectors, and all of this stuff inside a inheritance example. That was done last year by one of our mentors from Shazam, and that's this lecture right here. And it says the code is also attached, but it should be right here. That code goes along with these lectures. If you want to learn a little bit more about this, you really need to watch through these lectures. And if you want to make your program more dynamic, you need to watch through these lectures. And that's after you've watched these 9 videos, which you should already be done with, okay? These lectures, just to show you, I opened up some of the source code, I believe, on here. Let me just take a look. And that's not it. Yeah, here it is. So this is a program that uses polymorphism, and it creates a vector of animals, but it's a vector of animal pointers. And remember, vectors can grow and shrink. If you haven't looked up vectors and you want to look at that, just ask Mr. Van Gundy or myself. Email me if you'd like. It's Karen.O'Loughlin at, I don't know, ankenyschools.org. Mr. Van Gundy can give you my email if you need it. But notice that this is passing parameters. It's passing a zoo with a reference parameter. And what this particular program does is it shows polymorphism. And the only way to do that is to use pointers and the vectors here in C++. So the code, the sample code that's uploaded here has all of these files if you want to look at them and study them. But briefly, what we can do is we can still use, because it's a pointer, we can still use that bracket notation and work through. But if I'm using polymorphism, this particular zoo is getting all the animals and it's printing a report. But what happens is the animals, we don't know what type of animal it is. It might be a mammal or it might be a reptile, and the program has to act differently if it's a mammal versus a reptile. And so the only way to do that is do what's called polymorphism, okay? And in order to do that, we have to use these pointers, and we have to pass by reference and then use pointers to those objects. So you have to create a vector of pointers, whatever the overall base class is. So you'd create a vector of your base class. This particular line of code also shows something called a type definition. And so what they're saying is that every time I want to use zoo, a zoo is going to be a vector of animal pointers. And so down in my code, when I use a zoo, I am defined zoo as a vector of animal pointers, just because it makes it easier to work with. So instead of using vector animal pointer everywhere I have the word zoo, or I can use the word zoo, excuse me, instead of saying vector of animal pointers. And so this is actually a nice little piece of code, and you can use that in a variety of different places. You might want to Google type def to see what that's about. Okay, but you have access to all of this code to study, and it corresponds with that video link that I showed you on course sites. So if you want to learn a little bit more about that to make your last few programs kind of real spiffy, those are the things to do. But you should only do that after you have the bare bones done for your data files program, your inheritance program, and whatever else that you might still have out. That's it.